Okay, good morning, good afternoon, everyone. Thank you for joining us today for this webinar, Boosting Your Productivity Even Further. Really a look into our new release, SCIA Engineer 17.1, which will be released at the end of this week. My name is Ben Follett. I am the U.S. Product and Marketing Manager for SCIA. And today I'll be kind of going through everything that's come out new in 17.1. So before we get started, just a few kind of housekeeping things. The attendee audio will be muted during the presentation. However, you will have use of the questions box to ask questions during the presentation. Some of our product engineers have joined me in this presentation, so they can be answering questions during the presentation. We'll also have some time for you to put those questions in and have a question and answer session after the end of the presentation. Additionally, I always like to remember or mention that if you've got other colleagues that weren't able to join us today or just want to look back at some of the new things in SCIA, we are recording the webinar, and as soon as we're finished here, it'll be uploaded and posted on YouTube as well as our website, so you can view it again and ask any questions you have then. The last thing I wanted to mention before we go ahead and get started is we have an upcoming webinar on January 26th at 2 p.m. Eastern. It's a little bit later in the day. This webinar is mainly focused for our U.S. clients, all about the new composite design features in SCIA Engineer. So highlighting some of the really nice new features in the workflow, including automatic load combinations, different optimization approaches, the detailed output, integration with Revit, and validation of vibration checks for the floors. And so this is something that all of our customers have been asking for, and so it's something we wanted to certainly point people towards. And so that's you can just find the registration link on our website. Just go to our website and go to support and webinars, and you'll see the composite design webinar. And so before we jump into version 17.1, let's look back a little bit about what happened in version 17. So our theme of version 17 was boosting your productivity. And so we really looked at it in these kind of 8 categories. A lot of nice improvements for composites with the addition of diaphragms and automatic combinations. Just new technology really working to make this software more stable and faster. We did a lot of research and a lot of kind of looking in the mirror, if you will, to how we can make things in SCIA more robust. Obviously, there were big improvements in both the European concrete and European steel. In the concrete, just a more intuitive, transparent workflow was created, and in steel, more economical design through some of the additions of new provisions and stuff in the code, which allows for more economical design. For the IBC specifically, we had IBC steel updates for both cold form and hot rolled steel. We had some new improvements for loads, so more flexible wind loading and some new additions with overhangs and parapets and other things for automatic wind loading. In the scope of BIM, obviously we do improvements every release to our Revit link, so there were some improvements to our Revit link, but also some unique tax management with an integration with BIM Plus and some other things there. And then finally some usability, and really the thing that we're most proud of is being able to improve and add features to the software based on our customer, what our customers are asking for. And so we were able to implement the top 3 items that our customers asked for from a list that we provided in a survey. One of them that sticks out to me that I use all the time now is kind of the one-click export to Excel from the table results or table input. And so really trying to be reactive to what our customers need so that we can make the software better. And so today what we're going to do is we're going to look at boosting the productivity, kind of building on what we've done in 17 even further. And so we're going to do this in 4 main categories: concrete, BIM, some improvements to loading, and then also usability improvements. And so we're going to start here kind of with a hybrid of both, so looking at concrete and some usability improvements together. And so as you remember, in Release 17, we brought the implementation of 2D concrete design and the Eurocode and improved 2D concrete design, as well as speed improvements and extensions on different types of available output that you can get. And we also have this 2D concrete design for the IBC code as well. We also extended the design of those 2D members to allow users in the Eurocode to perform checks on cracking within slabs and walls. And in addition, the users were able to use different types of reinforcement within the cracking calculation. So all that was supported with a clear, kind of output and interface. And so in addition to that 2D member design, we aim to deliver a practical solution for the calculation of short and long-term deflections really in one click, really just being able to go right to it. So this feature was well received by clients. We got a lot of really great feedback about that because SCIA Engineer now offers those code-dependent deflection checks for both 1D and 2D members in a really quick and efficient workflow and really in a single click. Besides all that, we introduced a new and efficient practical solution for punching shear in the Eurocode, and we're going to talk a lot about this in this particular webinar. And so those are all things that we did back in version 17, and we're really trying to build on those things as we go forward. And so really, what's new in concrete design for the Eurocode in version 17.1? So as far as improvements are concerned, just general concrete improvements, new kind of methodologies for drawing with new results legends, some modification of the calculations in the Netherlands codes or the Netherlands annexes, new graphical representation of different effective sections. We've extended and added some national annexes, and we'll talk about those. And then what we'll spend a lot of time on is the improvements to the punching, shear, and check. And so we'll kind of go through all of those benefits, all those new things in a little bit more detail. So let's start here with output. So the first is just an output improvement. You can see here on the left here what we were showing as far as beams are concerned in 17 and what we're showing now in 17.1. So the idea here is improve the quality of the images and result data within the output, really to give us a more transparent and higher quality solution, including additional information about the reinforcement given. So we're not only giving the bars and the bar diameters, but also the area reinforcement, more information about the stirrups, just a better overall output. We also improve the calculation and the visibility of the effective section depth, or the effective depth D of a given section there. So really allowing the user to see what SCIA is doing so that they know exactly how the calculation is being performed, and if they have any issues can really verify that. All of this is meant to give better transparency. We also, for our clients in the Netherlands, improved the calculation of the compression zone and the compression zone limit XU. And so now with this new solution, SCIA can check to see if the members are under compression and check according to the required limit found in that Netherlands National Annex. So also with this new solution, the users will be notified when a member is under compression and when the check is being ignored. Additional functionality for the Netherlands Annex pertains to the failure of a stress limitation check, which the Annex doesn't support in releases 16.1 and 17. And so we would get this kind of note, this check, this unity check of 3, because the code didn't know what to do with it, essentially. Now when the user is utilizing this Annex, the check is automatically ignored according to the specifications. So it's not going to penalize you because obviously it's something that's not taken into account. The last new feature of this kind of general concrete improvement is the ability to graphically display bar sizes and spacing for provided reinforcement in a 3D environment. So this improvement really saves the user time and allows them for more efficient coordination of the overall design. So this is this is kind of what we had before, where we would just see a contour plot, and if we zoomed in on those areas where they are red, we would see that contour getting ever so tighter and giving us these different area provided reinforcement. Now what we have is maybe the data shows a little bit less on the slab itself, but it makes a lot more sense practically for how this is being shown, how you would model it. You can see here we're maybe putting this reinforcement in strips, and we're only adding additional reinforcement around the columns in this case, and we don't need reinforcement in those middle strips as opposed to those column strips. So really the idea is to take the results from a finite element analysis and allow you to better get them to the point where they need to go on your drawings or into your model. We also changed how the unity check is displayed. So in this case, again, using that contour plot, we see a jump from a 0 to a 3 unity check around the columns, and really this doesn't tell us a lot of stuff, tell us a lot of really good information. And so what we see now is getting a much simpler in much more basic unity check scaling. And so we can see, okay, here's where the unity check is okay, here's where it's not okay within those limits. And these are the same limits and the same coloring and the same kind of schema as other places in SCIA Engineer for 1D members and stuff like that. So, it's very familiar to the customers that are familiar with using SCIA. Like I mentioned, we've also done a decent amount of updates to existing national codes and annexes. So we've extended the concrete design and checks for both the Romanian and the Spanish annexes. We've also done some extensions for the Czech, Austrian, and Dutch annexes. So different extensions for design and for the requirements of the codes based on the needs of the users. And so we've made those updates so that we can stay as current as possible. Like I mentioned before, the last and probably biggest improvement for concrete was within punching shear. Obviously, we released some punching shear stuff in version 17, but really we wanted to build on these improvements. And so this first improvement that was made was for the punching shear check to be able to take into account openings in the slab according to the Eurocode. And so obviously there's openings punched in almost every concrete slab, and so the ability for the punching shear check to take these into account is really very necessary. We've also improved the presentation of the critical perimeter, which will help the designer to check how the software is taking into account these openings. And so here you can just see now you can see if we look at the check here, we can see that obviously if we kind of look in these areas here, we can see, okay, where the critical perimeter is not being shown or not being drawn graphically is where it's being influenced by the fact that there is an opening there. And so with that, we can actually, if we want to check this, we can actually go ahead and draw a line directly from the center of the column to the linear element directly to the corner of the opening. And this really gives us exactly how that opening is being taken into account. And this is right out of the Eurocode. And so it really makes it very easy for the user to say, okay, how is this opening taken into account? I know what the Eurocode tells me, and the Eurocode is like this, right? The Eurocode tells me, okay, well, I lose my critical perimeter in this area, just like we're showing there. And so we can really be able to visually verify this. And so it really makes things much easier for the user and much easier for people to understand and really kind of get rid of that kind of idea of black box. How is something being calculated? What is SCIA doing? I can't understand what SCIA is doing. And this way it really gives us a much better result and a much more robust reporting capability. Additionally, another improvement in this punching shear concerns the calculation of the actual reinforcement itself. So in release 17, the unity check would be greater than 1 due to the distribution of certain shear reinforcements. So it would tell us in this description that we're in a failing mode. So with the new solution in release 17.1, the calculated distribution of reinforcement has been improved, giving the user a more practical result. And so we have a more practical result, and we're also able to incorporate detailing provisions according to the Eurocode. So not just checking it for strength, but also, hey, what needs to be done around this column so that we get the appropriate result. And so you can see here we can check some of those where we've set the limits, and you can modify those limits or change those limits for that spacing and some of those detailing considerations that are going forward. In version 17, it was also not possible for SCIA Engineer to calculate the reinforcement outside of the first critical perimeter. And this can also lead to some calculation overstress. If we have to pack everything into that one perimeter, we're going to run into issues in some cases. So in version 17.1, this issue has been resolved, and the calculation of the reinforcement will be extended outside of that critical perimeter if necessary. Now, another improvement in this version was about the filtering of nodes for the calculation of punching. So in previous releases, every node that existed in the plane of a slab would have the check run for it. And so in the cases where we didn't really want this punching check to be run, we would get these Unity check 3, basically just telling us, hey, the check is not being executed properly on this. And so we really get unnecessary graphical and table results. So in version 17.1, the software will select only the elements that are required to make the check more clear. So obviously in this case we're ignoring some of those other nodes, and we're seeing that other information. We've also improved the output results. So in this summary output, so this is just kind of standard output, we see some better information for the shear reinforcement perimeters, the unity checks, the check if it's okay or not okay, and also the errors, notes, and warnings. So really kind of the information that the check is providing based on what's happening. So okay, it's not okay, but why is it not okay? What are we struggling with, right? And so we can see down here in this error, notes, and warnings, hey, the punching shear resistance at the basic control perimeter is not sufficient. Okay, so what do we need to do? We need to increase the reinforcement, right? Or we need to use a higher grade of material, or we need to decrease the thickness of the plate, or we need to add a drop panel. Whatever the options are, we're getting some data about what to do in that case. Kind of the last part of this general improvement inside the concrete setting and the design defaults are really around giving us better explanation of kind of what's going on and how we're doing things. And so in this case, we really want the user to understand the meaning of a certain setting without needing to read the manual. And so giving us that ability to show all that information right in the setup. Now I want to just kind of jump into a little live demo, because I think it's important for the punching shear check. So if I go ahead and start this video here, we're going to jump into the concrete service. So in the concrete service, I'm going to select the punching check, and you can see we can enable the required or provided reinforcement. We can choose from a combination. In this case, we're going to go ahead and look at the required reinforcement. We can set our extreme, and then we're going to go ahead and click refresh. So the check will run here, and we'll get our punching shear checks. So when we run the check, we get all the results, take into account the different critical parameters. We can see how the openings are affecting certain elements and certain members. If we really want to see how, how the opening is being taken into effect correctly, we can take a screenshot, and then just with simple sketching, I can go ahead and draw, like I showed in the slides. We can go ahead and draw from edge to edge to see exactly how the opening is taken into account. So you can see here are the missing portions of the critical perimeter. That's the portions that are basically drawn from these lines. And so it's exactly correct. So really easy to verify. Now if we go ahead and we can also look at the critical combinations. So right from within the check, we can explode the combination so that we can say, okay, I don't want to look at the full envelope. I want to check on one particular combination, and we can see the valuation of that combination for a check right from the check itself. Now looking at the summary results, like we said, we can see, hey, here's where the check's not required, but here's also where the information in the check is being used, and then what is the check telling us, right? So if we have things that are required, what's the results, what's the error warnings, but also, exactly what the unity checks mean. So what does, the shear reinforcement parameter mean? Now one thing I wanted to mention here, and I'm going to pause the video here so I can talk about this here, is just briefly, you might be wondering what the colors mean on the screen here. And so when we look at it, the green coloring here means that the concrete itself is okay for punching, so no reinforcement is needed. The blue means that some punching reinforcement is required. The single red line, which we don't have any of these in this particular case, is that we do need some more punching reinforcement. And then finally, the double red or kind of perimeter means that the slab is not designable. So in that case, we actually need to increase the thickness, add a drop panel, do something like that. So I'm going to go ahead and continue to run this video. We're going to switch actually to the provided reinforcement and see the results. Now in this case, we see that most of them are sufficient without punching itself. But we're going to go ahead and look at some of these results. So we'll look at this particular one and then get the preview up here. So we can see no shear reinforcement is required. That's because it's the concrete itself is fine. We can see the different information here that it's providing when we're looking at the type of reinforcement. Now we can go ahead and select that one condition that probably is going to give us the most issues. And again, we can see that we're running into a unity check that's not okay, and we're getting the warnings. And the warning here is the punching resistance in this place, we can't sufficiently design it, so we would need to make some changes. Now in this case, we can see again that with the provided reinforcement, we actually are we're actually able to design it based on the reinforcement, but if we needed to, SCIA is also telling us, hey, we can actually increase the thickness of the slab and maybe get rid of that punching reinforcement altogether. So just a summary of the concrete functionality. Really, we wanted to do the basic concrete improvements for better usability. That was kind of the focus there, is to have better usability of concrete in general. Obviously, we want to keep our current clients happy with the improvements to different national annexes and national codes. And then finally, with punching shear check, we really wanted to provide a competitive solution to what exists out on the market there. And I think that we've done that in allowing people not only better results, but also a better way to visually view exactly what's happening with the punching shear. And so there's no more guesswork, there's no more kind of trying to figure out what the punching shear check is doing or how it's working. You can see visually on the screen, okay, this is how this is calculated. You know, this is a great idea. This is, you know, really great functionality. So as we move on a little bit, we're going to jump into looking a little bit at some of the building information modeling improvements for this particular release. And most of them were centered around support and improvements for Autodesk Revit. So our link with Revit. So we've moved to support Revit 2018.1 and .2, so the first two service packs, and also the new version of SCIA Engineer 17.1, which again will be released at the end of this week. We've done some localization, so localization for main languages, English, and some of the other languages that we support, so better localization so that you can use the software or use the link in your local language as you're using Revit. We've done a lot of support really for the composite workflow like we talked about. And so support for metal decks and composite slabs, support for composite beam information, studs and cambers, support for joists and joist girders. We've done some enhanced material mapping. We've also added a new database for slim floor beams. And so that's really useful both in Europe and in the UK. And then obviously just done various bug fixes and improvements. And so I'm going to run this first video here. This is actually a model which we're just going to export from Revit to SCIA. And so you can see it's kind of a composite model. We've got some joists and some decks and some other things. And so we're going to go ahead and just use the link and export this information directly to SCIA Engineer to build our SCIA model. And so this is in many ways the way that people work for the most part. So they're doing something in Revit and then sending it to the analysis information. And so here you can see the model directly in the software. If we go ahead and select, for instance, this slab here, we can see, okay, this is a Volcraft 2VI composite deck. You know, it's got a certain thickness, it's got a certain deck profile. All of that came right from the definition of that in Revit. And the same thing here, we can see the metal deck here, or the joist in this matter, we can see it. The joist that was defined as a standard joist in Revit is defined as a virtual joist in SCIA for design. Now when we work in the opposite direction, so let's go ahead to the next video here. When we work in the opposite direction, we're going to go ahead and import information from SCIA. So now, like, let's just say in this same workflow, we did the model, we sent it to SCIA to do our analysis, add our loads, do our design. Now we want to bring that information back into Revit because we need to do our final documentation. And so in this case, we're going to import, either we would be updating or we'd be importing a new model. And so in this case, we are indeed importing a new model and building the new model, and you can see that all being built by that analytical model in the background. Now when the transfer is done, if there's any issues during the transfer, there might be something that pops up to say, hey, how do you want to define this particular material? And that's some of the improved material mapping. So in this case, hey, I'm going to choose that my metal deck be mapped as a metal deck material. So the import just finished here. So now we can go ahead and close out the link. We can see everything that's been added. And now the idea is we want to use the information from the composites or the joists or whatever to have that information available to our drawings. And so I'm going to go ahead and get us a few plan views. So the first is the composite view, plan view. And so we want to add information. So I'm going to go ahead into the beam annotations. And in here I'm going to use our structural framing tags with studs and our end forces. So we can see exactly here what we needed is, you know, we have the framing tags that include the studs and the camber that was designed in SCIA. We have the reactions, in this case just shear reactions because they're just pin connections. For the at the end reactions, if we needed moments, we could enable the MZ moment to show the moments on screen. And so all this information is available so that you can provide it to the fabricator or the architect or whoever needs this information for design purposes. And so that data is all available. If we go ahead and switch to the roof now, the same thing is available with the joists. So we design those joists in SCIA as a standard joist or a special joist or a KCS series joist. And so we can see that information if we go ahead and just switch to a standard tag. And so that information again is available. So we have joists, we have joist girders. So if we go ahead and click on the joist girder here, we can see that it's a specific joist girder, and it has a specific information in it, the number of members that are connected to it, and also the load. We can look at a standard joist or a KCS series joist in this matter, or even a special joist. All this information is available to look at based on it coming from the model in SCIA Engineer. So you're not adding this from scratch, you're adding it by just using the BIM annotations. Finally, we can go ahead and click to see, hey, what deck did we use? Okay, well, we have a 5-inch composite concrete deck in this particular model, and a particular Can-Am roof deck, or a particular Volcraft roof deck. So we have all of this information coming from a model into from SCIA Engineer directly into your Revit model now. Now the next, that was really our real focus for BIM was on Revit, and so the next thing that we improved was really the ability and some flexibility with loading and loading conditions in the software. And so the first thing, many people remember our addition for tributary area load distribution in load panels and in diaphragms and other elements in version 17. So what we've added, for those that aren't familiar, now SCIA has 3 different load distribution types: standard, finite element analysis, and then tributary areas. Essentially, a distribution of loads on beams is based on kind of the geometric configuration of those beams, forming kind of a grid. So you get spacings of where load is applied to a certain beam. So really the highlights of this is we reduce the amount of generated loads, so because it's just a simpler calculation. The results that can be easily verified, so you can verify them based on hand calculations. It's what we learned in university and college. We also get a better visualization of the loaded areas directly in the model, so we can see those tributary areas being calculated on particular members. What we added new for 17.1 was really the determination of tributary areas for surfaces containing and supported and unsupported openings. So being able to include openings and have those referenced in the model, I think, made a really big deal because, again, just like using openings for punching shear, every slab or has some sort of opening that needs to be taken into account. And so we need to take those into account not only in our punching shear checks, but also in our calculation of the tributary areas and the loads that are going to elements based on those tributary areas. Probably the largest improvement from a loading perspective, and this is specifically for the US market, is the improvement of live load reduction, or the addition of live load reduction in a building. And so many people may not know what live load reduction is, and so kind of just a brief definition. So since the probability of full live load on large areas is unlikely, the ASCE 7, which is the loading code for the US, utilizes the concept of influence areas in computing a reduction in loading for a specific member. And so this is obviously for the IBC environment. And it's really important for multi-story buildings with a focus on composite structures. So the idea here is that even if you have an office building structure, and the office building structure has 40 pounds per square foot, and that's the live load that you have to design for, the likelihood that you actually have 40 pounds per square foot on every single beam or column in that building is incredibly unlikely. And so how do we take that into account so we don't over-design and cause material costs and construction costs to go through the roof? And so it permits this reduced live load. So it really gives us allowable reductions up to 40 to 50% of the original load. And it's based on this equation. So each member requires a different reduction. And so that's why this is a really complex kind of thing, even though it's easy to do kind of by hand because visually it kind of makes sense with tributary areas. It really requires some heavy computing because everything has to be done on its own. So here you can see the equation here. We've got the original load, some factoring, and then this KLL factor is actually based on what type of element it is. So if it's a column or a beam or an interior beam or an exterior column, that KLL factor changes. And then this is the tributary area. And so you can see these tributary areas being calculated. And you can see then the influence that that element would get for this particular thing. So in this case, an influence for that edge beam is that whole bay. For that central beam, it's these 2 bays together. For this edge column, it's that bay. For this other edge column, again, we have these 2 bays. And then finally, for this central column, we've got this influence of this larger bay area. And so you can see, because of this, we're able to use a higher or lower reduction. And so what is all included in the implementation of live load reduction in SCIA Engineer 17.1. So we have an automatic reduction for beams and columns. We have all results are graphically verifiable. So you can see the reduction factor on screen, you can see the area that it's using to reduce that on screen, you can see the influence area, all that information you can see visually on screen for a beam or for other, a column or whatever. It includes tolerance for eccentricities, so this is really important for complex models. So when you have a complex model where you have maybe columns that are slanted, or you have columns that aren't really exactly in the location, it can take that into account, and you can decide how you want to do that. There's a really robust derivation for influence areas, so it's not just for the simple, right? It doesn't have to be just a very straightforward, simple, rectilinear problem. It can look at really complex, and this is kind of how it's doing it in that picture down there, looking at really complex with openings and different things to figure out the final influence area. Probably the biggest thing is it's code compliant. So you, the user, control the loading for the the load groups that you want to be reduced. You would select, hey, I want to reduce this roof live load, or this heavy live load, or this regular live load. That's all up to you. And then it really uses the actual calculated areas. So it's calculating based on, hey, if this beam is loaded here but not loaded over here, it's not going to take that into account because there's no load there. And so it shouldn't penalize you for area that's not actually loaded, even though the beam has that part as part of its tributary area. So it understands that. It's intelligent enough to understand kind of what's going on in that particular case. Okay, the last main section here is some improvements to usability. And so the biggest one that I'm super excited about is the ability to lock results. Really, the ability to maintain results while making model changes really gives the user the ability to view results and view checks and create tables and create images, all without needing to recalculate the model. So what you do in this case is very simple. You've got a model. You want to lock your results so that you can make some slight changes. You want to do some member changes because you're optimizing for steel, so on and so forth, but you don't want to lose all the results to that model. You can go down here and click the lock or the result lock button. So I'll just make that a little bigger. Click the result lock button, and then SCIA will tell you, hey, you've got this locking results switched on. Results no longer correspond to the model, so you're a little bit out of date, but in some cases that's okay because you know that changing and updating this one beam because of this 4% overstress is not going to change your stiffness or your self-weight of your structure all that much. So in that case, it makes a lot of sense to be able to allow you to continue to work without losing all your results. And so that's kind of the benefit here. And when you're ready, you can unlock them or just rerun the analysis. The other, and this is I think more beneficial for the US market, is now we have defined unit sets in the project data. So whereas many of the things, we had unit defaults for the Imperial Code, but one of the things that didn't exist was if you went to add a beam or you went to add a column, the base length or the base size for the mesh or something like that wasn't a standard Imperial unit, basically. It was a meter in feet rather than 3 feet. And so we've now created default unit sets, so you just choose which default type of unit you're going to use, and so we'll choose the Imperial format. You can open up the unit dialog to set your units, so hey, I want to use kips instead of pounds or inches or whatever. You choose what you do, you can save that as your default, and so all of these metric and Imperial units for the input of structure, for loading, for members, for properties of members, as well as mesh and solver setups, those all exist. And so it just allowing people to work better and more efficiently and not having to make changes where the software can do the work. So before we kind of wrap up and get into some questions, just a quick review of the main things that we've talked about, obviously in these 4 categories. The first, really focusing on concrete, so a one-click punching solution. That was the biggest thing in this particular release, and I think the thing that our customers are going to be really excited about in the improvements of punching shear as far as it goes to our overall concrete design, especially slab design. Obviously, we added new national annexes and improved some of the national annexes, and we also did a bunch of display improvements, like we talked about. So a bunch of improvements to how 2D outputs, or how display was done on 2D members, or how it was done on individual drawing of reinforcement in a 1D member. We also improved our Revit link. That was a big improvement this release, and so with all the information for composites and joists and different things, all that information now to really complete that composite workflow was added in this Revit link. Loads, we extended the tributary area to include openings. That was a big thing that we needed to do to make sure that those calculations were done right and the vast majority of slabs could be accepted. We could use tributary area on those types of slabs and decks. And also we added live load reduction. Super important for steel buildings in the U.S. market alongside of composites. You know, it's standard operating procedure for things that need to be done. And so we wanted to get that in there, but not just get it in there in a way that really helps the users and it provides them information so they know exactly what SCIA is doing. And then finally, the usability improvements with the result locking and the default unit sets, just some more information, some more data to allow the user to do their job a little bit more efficiently and really have to do less clicks and less analysis and less changes to things in the model that really don't affect the overall end result that much. And so with that, we'd like to open it up to questions. I know that there have been some questions that have been going back and forth in the questions tab. So if you see the questions tab there in your GoToMeeting kind of box, you can go ahead and type your questions into the box, and a few of our product managers who are available here will can answer some of those questions for you. I can see that there's always been already been some answers or some questions about punching shear that have been answered by my colleague Marwan. So we can kind of wait here to see if there's any questions that kind of pop in. I know one question that we always get for new people that are interested in the software is does SCIA do a trial? Yes, we do a trial of the software. It's a full 30-day version of the software, 30-day trial. It has all the functionality, so there's no limitation to how many nodes or members or whatever that you can put in the model. It's just a matter of applying for it and getting it approved. And so if you just go to our website, scia.net, and there should just be a button for free trial, you can fill in your information, and that will go to the local salesperson, and they'll be able to contact you and improve that trial. So we had some questions. Let's see, we have a few questions coming in. So they're coming in fast now. Yeah, so there were questions. Yeah, so we can just a quick review of some of the questions that were asked and answered already. So the first question was, is the punching check undertaken on transfer columns loading the slab from above? Yes, that is taken into account automatically, and you have the possibility to see that value graphically. Somebody asked about the single check functionality for punching. That's not yet supported. However, the new solution will take into the possibility into account, and everything will become automatic to save time. And so really it's just kind of rolled into there. We had a question about the corner situations, basically having re-entrant corners for punching shear check, where we have these kind of dead zones. You know, so really a question about the critical perimeters. So the calculation of those critical perimeter reduction is done according to the code. So I mean, it's matching exactly what the Eurocode says it needs to have. If we continue to look here, we had a question about relative displacements of the slabs for the model on spring supports. Can this version show it? There wasn't any specific update to the visibility or the viewing of relative displacements for slabs. That wasn't something that was specifically done in version 17.1. Obviously, I'm not 100% sure of what exactly you're trying to do, and so I know that obviously there's a lot of robust output that's available in SCIA, and so certainly that's something that we can look at doing, or may be able to give you some sort of output in that case. So there's a question about the locking of results. When the results are locked, can you reanalyze to see the new unity checks, as in the case of existing structure being repurposed and needs verification if adequate? Yeah, certainly. So you can certainly do that. You know, in that case, if you got a structure, but you know, you would lock, you don't, in that case, you might not even really have to lock the results. You would just basically make sure that you're not making updates and changes. Even when you're doing a check or an optimization, you have to run the check, and then you can proceed to do an optimization. So you don't need to, it's not just kind of one fail swoop to say, hey, I'm doing a verification. I don't want to just press a button and have all my members changed to meet Unity checks. So in that case, you can go ahead and just run the checks rather than the full optimization. Let's see. So someone asked about notional loads in the Eurocode, and this is a question that we get a decent amount, even in the US code, because they're really important for the direct analysis method. The question really with notional loads is, what are you using notional loads for? Typically, the notional loads are used to approximate the ability of, or the construction having out of plumbness and out of straightness. And so that out of plumbness and out of straightness can actually be automatically applied within the nonlinear cases and combinations through what we call what we call global and local imperfections. And so that's a nonlinear option in the software. And so in that case, when you're using that functionality, you don't have the need for notional loads, because notional loads are really just used to apply them at the top of a member and give you that out of plumbness and out of straightness. And so there's a way to do that without needing notional loads at all. Let's see, what else do we have here? So there were some questions about some of the new stuff in SCIA people, and you know, we'll continue. We do have another release that will come, or another main release will come kind of in the springtime, probably the April-May timeframe. That'll be our 18 release, where there's a lot of new functionality that we've been working on, and a lot of new things, new improvements that will be included into that particular release. And so some of the preview technology of that will be, you know, will be kind of throw out probably after the new year, with people starting to kind of get involved with that. Additionally, like I mentioned, the release actually will happen on Friday, and so that will be actually maybe it's tomorrow. So tomorrow or Friday, the new versions will be available on the website, and all the helps and resource center and everything will be updated with you know, all the new features for you to have. All the help pages are done, and videos and stuff like that. So that'll all be available to the user so that you can see exactly what's happened and what's changed. Let's see. Okay, it doesn't look like we have too many more questions coming in. And so I think at this point, you know, if there aren't, obviously if you have more questions, we'll be happy to answer anything. You can contact me directly, or contact our general support at support@scia.net. You can contact me directly. Mine is b.follett@scia.net. So my last name, Follett @scia.net. I'm happy to answer whatever I can. I'd like to mention again, just for those that maybe came a little bit late in the presentation, you know, join us for our upcoming webinar. We're really excited about the composite functionality in SCIA Engineer. And so the whole workflow, whether it's modeling or automatic creation of load combinations or optimization using web openings, providing easy verification in the output, doing Design Guide 11 verification for vibrations, and then transferring all that data to Revit like you saw a little earlier today. All of that, you know, we're really excited about that workflow, and we'd like to go and show you the whole workflow. And so that webinar, like I mentioned, January 26, 2018 at 2 p.m. Eastern. You can use that link there below to register for the webinar. We'll be obviously sending out e-blasts, and it'll be in our e-newsletter and posted on different social media, LinkedIn and stuff like that. But until that time, if you have any questions, please feel free to contact us. Look out for the external release emails and newsletters that will be going out in the next few days so that you can install the new version of SCIA Engineer. And if you have any questions, we'll plan on following up with people post the webinar. So thanks very much, everyone. Thank you for joining us today and learning about SCIA Engineer 17.1 and how you can boost your productivity even further. Again, my name is Ben Follett, and we thank you so much for joining us. Take it easy and have a great day. Bye-bye.